Okay, the first thing I want to do is check and see if I've made any changes to this code. And so I'm going to do a commit, and I see that there's several things. These are all projects. I don't care too much about those. I'm going to look and see what changes I've done to this matrix multiply. And I look through here and I go, oh my goodness, yeah, these are changes that I did in class the other day that were just trying to demonstrate stuff. I don't really want them to stick around. And so I'm going to get rid of those changes. So I'm going to cancel the commit, right click, and this time I'm going to, let's see, revert. So I'm just going to throw away those changes I've made. So I'm going to say, which ones do you want to revert? I just want this one, the C++. Bang, and it puts it back the way it was before I made those stupid changes. Okay, the next thing I'm going to do is open up Visual C and get ready. So I'm going to pause for a minute. Okay, all I've done is opened up my Visual C program, and I've opened up the multiply file again. And what I'm planning to do now is to move all of the matrix things into its own file and use a structure. So I'm going to create a file on the disk and then include it into this Visual C. So I'll pause until I get that finished. This is what my directory looks like that has the files. I'm just going to create a new folder, or new file, new text file. Let's see, text document. And I'm going to call this matrix.c. And I'm going to create another one, matrix.h for the headers. I'm going to include those in the project. Okay, I'm back here, and what I'm going to do is right click, add an existing item, matrix C, and then for the header files I'm going to add existing item. So now they're in the file. If you build it, should do just fine, because there's really nothing in that matrix C. See it open. Well, I'm going to pause it and figure out what I'm doing wrong. Okay. After I read it for a little while, I don't know too much about C++. I've already admitted that. And so all I did is I changed the matrix to a C++ file, and now the include file works fine. What this does is oftentimes, especially in C++, you have a lot of files that get included, and it takes time for it to read those things in. And so they have what they call a pre-compiled header, and it's you know, stdafx is your pre-compiled header, and once that gets all read in, then they just include it, you know, in one fell swoop right there. So that's what was going on. But anyway, so now the thing will build and succeed. Okay, the next thing I'm going to do is start defining some matrix structures. Okay, what I've done here is made some minor changes to the matrix C file. I've included this include matrix H. Let me show you what I've done in matrix H. In matrix H, I have used a couple of new things. One is a definition. I like to use definitions when you have numbers that might change. So for example here, the maximum number of rows and maximum number of columns could change. And if that's the case, I like to put them in a definition and then use that definition in places I'll show you here in a second. The other thing I'm showing you is this type definition. These are used a lot. Basically, what's happening in a type definition, in general, it'd be type def, and you could say I'm going to call a something called my float, and and it will be a float. Like this. So you know that we have integers, floats. Let me take a look at what this error is. Okay, kind of shows you my memory. So what a type definition is it says my float is something I'm going to call a new kind of variable, and it happens to be a float. So now, instead of defining an integer something, right? You know what that is. You could say I want a my float something, and so now sum is a my float. What's a my float? It's a float, which is kind of stupid, but when you use them with structures, they become very powerful. So anyway, here, but you can do a type definition for anything you want. Here what I'm doing is I'm defining something called a structure, which I'll talk about in just a second. And a structure is going to be, a matrix rather, is going to be a structure. Now what a structure is it's a new kind of variable that allows you to mix, like an array you would have like these elements here. This would be a set of floating point numbers, and there's going to be 10 by 10, so there'll be 100 floating point numbers in here. That's how you do an array. Now the structure is very similar, except for the fact that you can have different kinds of variables inside the structure. So in this case, a matrix is made up of one integer, which is going to be called number of rows, another integer, which is called number of columns, and then a 100 element of floats, which are going to be we're going to call them the elements, and they make up the matrix. So what I'm going to do then is get rid of this junk, and so that's, and the reason I'm putting it into H, the matrix.h file, is because anybody who uses a matrix is going to include this matrix H file, and then they'll know what a matrix structure is. So let me show you how that impacts the main program. So here's the main program. And so in the main program, first thing by the way, in the matrix H, sometimes you can get confused where the matrix H is included multiple times. You want to try to avoid that. It can create confusion and whatnot. So the other thing I'm using here is an if statement, and this occurs at the compile stage. And so this would be if matrix H is not, you see that in there? It means not defined. So if matrix H is not defined, then you define it, and then you go ahead and include this file. If for some reason somebody else has already included it and it's not needed anymore, then matrix H is already defined, and when it hits this statement, whoops, what did I do? So when it hits this statement, it'll say, well, matrix H is defined, and it'll jump down and through the end statement. So that forces it to only include these files one time. You can probably get by with that, but I'll tell you, the first time you get a repetitive inclusion of these H files, you'll wish you had done, you'll wish you had done this. Okay, so here's the main program, and in the main program, I'm going to use matrices, and so I include the matrix. Incidentally, at this point, let me just pause for a minute. You see there's two different kinds of includes. One includes these with these bracket things, and the other one is with quotes. The bracket is used when you are including a file that is provided with the compiler. So standard IO is included with a standard C compiler, and so you put it in brackets. If you use quotations, that is something that you wrote, and you generally store it in your directory where you're keeping your project. So that's the difference between these two things. Okay, so now first thing I'm going to do is I used to have a first, a second, and a multiply matrix. So this time I'm going to use this structure called matrix, and it's going to be first, second, multiply. So this is how I get 3 matrices in the main program. And now let's just modify some things. So here I'm trying to enter the number of rows and columns in the first matrix, and it used to be called M and N, right? So now what I'm going to do is I'm going to I want this number of rows and columns to be stored with the first matrix, and so here's how you do it. You know what that little ampersand thing is, and that means the address of where M is living. So I'm still going to use that. But what I'm going to do is I'm going to say I want this to be, when I read it in, I want it to be stored in the first matrix, and I need to tell it which part of the first matrix. So I'm going to hit a period, and the editor pops this up and it says, here's what is inside the first matrix, and I want this to be the number of rows. So I select that and get rid of the M. I don't need that anymore. So what's going to happen is when it reads this number, it's going to store it in the first matrix number of rows. So the N, that is going to be the first matrix number of columns. So here we go. Okay. Oops, I didn't want elements. I wanted number of columns. There we go. All right, so I've read that in. Then we want to enter the elements of the first matrix. So that would be down here. C goes, okay, now the M is number of rows. So let me pause that. I'm just going to edit all this. Where I used to have an M, I'm going to put in number of rows. Where I had a N, I'm going to put in number of columns. Okay, so I believe I've gotten the M and N proper. I have the first number of rows, number of columns. We have another issue right here. You see that little red underline? So what I should be reading here are the elements. And so what I need to do here is say first decimal point. These are elements. Whoops, I always screw that up. Elements, hit the tab, C and D. All right, so now I'm reading into the elements. So this should store the value. Now, typically what you would want to do when you define this matrix, stuff, you should take everything that's related to common processes with matrices, like, for example, reading in values. You probably ought to take that, make it a subroutine, and put it into the matrix CPP file so that it's there, because everybody's going to have to read a matrix or multiply or whatever they're doing. And so you should take all of those operations and get them out of the main program and put them into the matrix CPP file, so that whenever somebody uses your software, they have the ability to read the matrix in, print the matrix out, multiply them, whatever it is that they want to do with the matrix. It ought to be in the CPP file and not in here. So I can leave that for an exercise for y'all. Okay, so here I'm going to basically do the same thing with the second matrix. We're going to read in the rows and columns, and then we're going to read in the elements. So I'm going to pause and do that and then get back to you. Okay, so what I've done is I've made those changes. So now we've read in the columns and the rows. We've read in the elements. Now here's another thing that I'd like to point out. Right here is an error check to make sure that these matrices can be multiplied. This really should not belong in the main program, because essentially what you're doing is you're expecting that the person who's using your software knows that the number of rows of the first matrix, the number of columns of the first matrix have to match the number of columns in the second matrix. Typically these error checks like this ought to be done in your program that you're doing the matrix multiply. Now, if it's a matrix, everybody ought to know that that's an error. But if you're doing something more complicated, writing to a screen or doing whatever, it's not always, it's not always a good assumption that they know what they're doing. And so you want to protect them from doing something stupid. And so you want to take all of your error checks and you want to put it in there. That's why you want to do it. So what I'm going to do is I'm going to rearrange this so that I read in the first matrix, and then I read in the second matrix, and then when I call the multiply routine, that's where it's going to decide whether or not it has an error. So I'm going to just essentially remove this if statement here in the main program, and we'll put it in the other one. So I'll pause and then get that done and bring it back to you. Okay, so what I think you can see I've done here is I've just commented that out. I'll delete it here in a minute, but I'm just going to leave it there for the moment. And so it reads the number of rows and columns in the second matrix, and then it says enter the elements, and so it reads in the elements. So I've got the first matrix, I've got the second matrix. Now let's see how you're going to do the matrix multiply command. So down here it's complaining because it doesn't know what M and N is. I should get rid of P and Q. I don't need those anymore. So I'm going to get rid of P and Q. So we'll get rid of those guys. And so it's complaining that it doesn't know these values. Well, that's okay. But what I'm going to do is I'm just going to change the way I call it. I don't need to send it these dimensions anymore because they're included in the first and second matrix. So we're going to delete those guys. And then the way I'm going to bring this value back is I'm going to include the name of the other matrix. So that would be, I think I called it multiply. If I can spell it right, multiply. Okay, there we go. It doesn't look right. Anyway, okay. So what I'm going to do is I'm going to change this thing so that it accepts three matrices, the first, the second, and basically the result. So now the reason it's complaining about this is the fact that it doesn't match the prototype. So what I want to do is I want to go up here and change the prototype. And so when I call matmul, I no longer have to include the number of rows or the number of columns or the number, this one. And now this is not an integer. What it is it is a matrix. Matrix first. And I don't have 100 matrices that I'm sending. I'm sending one matrix. And here this is also a matrix. Not 100 of them, but one of them. And then a matrix and multiply. Okay, so I've changed the prototype. So if you come down here, it's now no longer complaining because it matches the prototype. Okay, so the next thing I need to do, hang on. Sorry about that delay, I had to sneeze. Okay, so the next thing I want to do, well, I need to change this print thing here. I'm going to pause and I'm going to change the way I print, and basically it's going to be the I have to change the number of rows and columns and all that. So I'll get back to you in just a second. Okay, so what I've done is I've just changed C goes to the multiply number of rows to the number of columns and multiply, and then I print out the elements. So I've just changed that to use those guys. Now, like I was saying, okay, so let's go in and do the change the matrix multiply routine. And what I'm going to do is I'm going to grab it from here, I'm going to cut it out of here, and I am going to paste it into the matrix.cpp. So here we go, it goes in here, and include it right there. All right. This doesn't match the prototype. I'm going to fix that in a minute. Now the next thing that you want to do is, if you look over here in the main program, you have your prototype for matmul. The prototype should not go in here, but it ought to go into the matrix.h, because everyone who's going to use matrices is going to potentially want to do a multiply. So I'm going to cut it from here and I'm going to put it into matrix H. Now you want to put it after your definition for a matrix, otherwise it won't know what first and second and all that is. So I put it over here in the matmul. Let's go to the matrix, I'm sorry, and let's get this multiplication thing working. This guy, I don't know why I put it in there. I don't know what I was thinking. We don't need that because they're going to be sent down to us. Okay, so let's modify this. So the first thing is that this thing is going to be a matrix. It's going to be called the first. And then I have a matrix second, or whatever you want to call it. And the final value is the matrix multiply. All right, so now it knows what I'm sending down. Okay, and let's kind of get rid of this. The multiply is not I'll just comment the thing out. It's not this. It's being passed down to us. Okay, rows in the first matrix. Okay, what I need to do is I need to specify rows in the first matrix. That's going to be first dot. Okay, so I think you know what to do here. So first dot, and it's number of rows. Boom. Okay, get rid of that. I'm going to make all of these similar changes. So I'm just going to pause it till I get it done. Oops, I should have read this before I paused it. This right here is doing that error check to make sure that the number of columns of one matrix equals the number of rows of the other. And it's all kind of messed up, but this is where the error message is going to go. So what I'm going to do is, in order to multiply these, the number of columns of the first matrix has to equal the number of rows of the second matrix. So that's what I'm going to do here. So if first dot number of columns is not equal to, so in C, equal means a logical test. Is this equal to this other thing, right? You're asking the question. If you want to say, is this not equal to this, you can put a exclamation point, not equal. If the first number of columns is not equal second number of rows, then we have an error. So we'll return a 1. Now what I like to do is also define these error terms. So what I'm going to do is go over here to the matrix H so everyone will know, and I'm going to say I'm not sure I have the right syntax. I'm going to pause for it. Okay, so I'm using an enum, which stands for enumerate, and it's a shorthand notation of you list these names down here. There's various forms of the syntax, but this is the simplest one. And success is a word that is set equal to 0. So that would, whenever you see the word success, it's a 0. Bad row and column, that's a 1. If you had something else, these are the error returns that I'm going to use for this thing, and you can call them error returns or something. Matrix error numbers, whatever you want to call them. And so now you have something to return. Okay, so let me show you how I'm going to use that. So then over here in matrix matrix C++, what I'm going to do is, if these do not match, I'm going to return bad, what do I call it? A bad row and column or something like that. Bad row call. So I'm going to return bad row call rather than a 1. All right. So then if I ever decide to change this, I just have to stick something else in here, and then the compiler takes care of it for me. Okay. So bad row column. So if you can't multiply it, return bad row column. It's up to the user to receive that value and say, oh my goodness, I made a mistake here. So now what I'm going to do is I'm going to pause, but I'm going to change all of these numbers to the correct values. So I think you can do that. Okay, so now what I've got is I've changed all of those to be the, oops, I missed one here. First and second, I missed 2 of them. First dot elements, and I spotted that when I saw that little red guy underneath dot elements. Okay, so now I believe I've got everything changed. So now, it defines the elements, and then the multiply elements are defined, and then you can return them up here. What I have forgotten is I need to tell what the multiply rows and columns are. So let me do that. So for example here, multiply dot number of rows should equal the number of rows of the first matrix. And the result number of columns, number of columns will equal the second number of columns. Bang. Okay, so the number of rows, number of columns, and the elements are all defined. So this should work just fine. I'm going to compile it, and I'm going to pause it so you won't see any errors. Okay, what happened here, there were some errors, and they were in ones. I still have some, but here the elements are now floats, not integers, and so when you're reading that in, you need to use the format for reading a floating point. So I changed that one. I changed this one, and it didn't, in here also, because when you print it, you're going to print this thing. The other thing that it's complaining about, it's a warning, I guess, is that there's a variable k, which isn't used anymore. I forget exactly what it was for, but I'm going to get rid of it and build. And initialized, okay, I'm not exactly sure. I think I know what this one is, but I'm going to I'm not sure what I'm going to do. I'm going to pause it and get this thing fixed. Okay, so what it was complaining about is it was trying to tell me that when I was passing multiply, the matrix, down to this routine, it was warning me that I didn't, it had nothing for multiply. It hadn't been defined. And so what I'm going to do is I'm passing the address of the multiply matrix, which is probably what I should have done to begin with. Anyway, and so the multiply address is defined because you say what multiply is. It's a matrix. So what I did was I just added with an ampersand here. So I'm saying I want to pass the address of multiply, and that way, that is defined. So what I have to do then is I have to change the prototype, and so I have to say it's an address, and then in the matrix routine I have to accept it as an address. And when you're dealing with a structure, the address of a structure, the way you get the values is you make a little arrow, which is really two keystrokes. It's a negative and then a greater than, so it looks like an arrow. So multiply that points to the number of rows. So that's how you deal with that. See, first doesn't have that. It has a decimal point because it's a matrix. This multiply has this little arrow symbol because it is a pointer or an address of a matrix. So I've made those changes throughout, and then when I recompiled it, it's complaining about this one, which is, let's double click that. So what's happening is it's warning me that first and second now are floats, and I'm adding it to an integer, which was an oversight on my part. And so it's just warning me that you're going to lose. It's going to round it off, right? And if you really want to do that, that's fine. But otherwise, I'm going to make some a float. And it's probably complaining about the other one too. Was this, let's see, int to float, possibly, yeah, same thing. Probably same area. And enum. Let's see, what's it complaining about here? Let me pause it. Yeah, it was basically complaining about the fact that I had a name here. So I just removed that, and now it's not complaining to me anymore. All right, not sure why it was doing that. Okay, so there's my matrix multiply routine that uses the others. I'm going to put this in my SVN, and I'll post it for you as well.